understand it though.
All right, so all right, guys, pay attention. Pay attention. We gotta go. We gotta go. Why it's not showing? Okay.
Maybe it's just skateboard theme. Yeah. I don't understand it.
Very cool. After use, it has to be a nightmare. So I'm
Actually, illiterate. Have to use your own languages.
Yeah, it definitely is.
Who's just skate theme.
All right.
Another story about that. This one's kind of I mean, you know Nick Roman? Dude, like,
All right.
this dude had like 3 infractions, crashed his car, he had like 4 tickets. After better than him.
We are talking about telescope series yesterday. So the question is the one that you have to do something. So I'm gonna ask you to do it. Last period they already did yesterday. So I'm gonna ask you to do it. The question is looks like this. It's summation of n equal to 1 of infinite 4 over 4n, sorry, 4 over 4n squared minus 1. So this is telescope series. Where's Daniel? He was here, right?
Yeah.
Okay. Okay, so this is telescope, believe it or not, but what's the condition to be a telescope? What's the condition to be a telescope series?
The later turns cancel out former turns.
Okay, but before that, usually that you are gonna see telescope, it's gonna be what? Look at yesterday's example.
They're like cancel out.
There's 2 fractions, right? And 2 fractions subtract each other. That's a series itself. They have 2 fractions subtract each other. But this one doesn't.
Split.
How do you split?
Partial fraction.
Decomposition.
Okay, so I want you guys to figure out the answer to this one. Yeah, so sometimes it's hidden. Usually you can tell it's bottom's factorable. If bottom's factorable, I would just factor it and change it to 2 fraction. Usually, probably 99% of the time, it means complex. It's gonna be means the something's factorable. That means you can do telescope series, but it has to be factored. Not factor the bottom and just do decompose.
This is the same example from yes.
Yeah, did you finish it? Did you finish yesterday?
I mean, I watched the video from yesterday.
Oh, okay. But the
Yeah.
6, yeah, they didn't do it.
Oh, they 7th period didn't do it.
What'd you get?
2.
Is it 2? This one?
Yeah, it was.
Yeah.
Yeah.
Okay, so yeah. Very cool, very cool. Now, what we're gonna do is, so we learned the first series yesterday, which is telescope series. The condition usually is usually like rule of thumbs, right? Usually is the bottom is able to factorable. Usually it's 2 fractions, subtracting, or factorable on the bottom, factorable on denominator. Factorable on denominator, and then you can decompose. So usually is telescope series. So that's that. No big problem. You'll like today's series. Today's series is actually interesting. So now with that being said, I'm gonna go to the next series. The next series is very well known. Everybody have to know this. It's called geometric series. I will say this is the only series we use all the time that never miss in any single AP exam. Telescope sometimes show up. I say 1 out of 4 chance show up. Geometric show up more than once. So if one series you have to know is geometric. So let's just talk about n equal to 1, infinite a to the r to the m minus 1. This one's going to be a plus a to the r plus a to the r squared, a to the r to the third, to the a to the r to the m minus 1. This is very, very well known. Sometimes it could be like this. I did forgot to mention on last period. It could be like this. N equal to 0. But don't you, this one's very rare. Very rare. It's r to the n. So it's just basically one term on the left. It means exactly the same thing because you start at 0, you end with n. But it's more well known this one. So this is the most popular. Most popular one. This is very rare. Okay, this is very rare. It converge when absolute value r is less than 1, or -1 less than r less than 1. So r is less than 1, but absolute value r less than 1 means from -1 to 1. Diverge when absolute value r is greater or equal to 1. Now some people are gonna be like, why? I'm gonna explain why in a second. The sum is summation of n equal to 1 of infinity of a times r to the m minus 1 is always equal to a over 1 minus r. This is a root of all things. If you want to learn just on problem solving, this is the equation to know.
What happens if it is 1?
What happened is what?
If it is 1,
Is diverge.
but wouldn't it just stay?
Yeah, so imagine if you have a number multiplied by r, right? So for example, 5 multiplied by r is 1. So it'll be summation of 5 plus 5 plus 5 plus 5 plus 5. So it's always going to be diverged because that 5 keep on increasing.
So a is just any number?
Yeah. So if you have r is 0.99, the number is going to become smaller and smaller and smaller and smaller. Then it's always going to converge. Does that make sense? Rebuff, does that make sense? Okay. So imagine that you're eating one pizza a day, right? That's going to be infinite on pizza. That's assume that you live forever. It's going to be not going to be finite. It's going to be keep eating pizza, right? Now, if you eating, let's say r is less than 1, let's say you're eating half as much as the day before. So that's r is half. So let's say first day you eat one pizza. Second day you eat half pizza. Third day you eat 1/4 pizza. Fourth day you eat 1/8 pizza. 1/16. But if you keep on adding up, it's only going to be 2 pizza at the most. Does that make sense? Visually, this is what happened. If you eat one pizza the first day, okay, second day you're gonna eat half. I'm gonna draw it out just in case. The third day, you're gonna eat this. You're gonna eat this, and third day is gonna eat half the day before, and half day before, and half day before. It doesn't matter how I do it. It's always gonna be finite into 2 pizza. And that's very important example because we're gonna do that later.
That's converge or
That converge because it converges to pizza because r is half. If r is half, then it's okay. R is 3/4 is okay. R is 99/100 is okay. Now r is 101/100 not okay. Because r equal to 100, a 1 is not okay. Because you can eat one pizza per day and you eat to infinite, then it's gonna be. But if you eat 99% compare the pizza before, the day before, you still eventually it's gonna get down to a finite number. Does that make sense? Now I'm gonna show you an algebra proof of algebra equation. So the algebra equation is called finite geometric series. It looks like this. Sum a times 1 minus r to the n over 1 minus r. This is the things that we use to find out. So if I eat a pizza the third day, the fourth day, how much pizza I totally eat is gonna be like this. But remember, this is infinite series. That's assuming it's going to infinite. We are not going to do that. We're going to find a finite. Finite is going to be a times 1 minus r to the n over 1 minus r. Now you're going to say, well, where's this formula come from? You learned this in Algebra 2. I don't know if you remember, Daniel.
a little bit.
This is the Algebra 2 equation.
No, I remember I said like the a1 over 1 minus r, but that was what I remember.
Okay, that's called infinite geometric series. Now, if you did this, you say, oh, okay, well, where does this come from, right? Where does this come from? So I'm going to show you where it come from. Imagine that this is a Sn, that means sum. And sum is going to add the first term. Every term I'm going to multiply by r. Is that okay? I'm going to stop at the term before. Because that's the formula that we are using to. Now, what are you going to do is we're going to multiply by... This is very, very cool, by the way. I never tried to attempt to explain this, but once I understand it, I was like, wow, this is an awesome equation. They multiply by r both sides. And I don't know who does this stuff. This is like amazing stuff. Like, who will come up like say, let's multiply r on both sides. But what's interesting is, if multiply by r, that's going to be r to the Sn, right? And that's ar, would you say? Plus ar to the 1 plus, huh?
No, Then we add the squared.
r to the square plus a r to the third plus we also we do the four wait we will do r this is r square, you're right, this is r square and this is 3, oops, this is 3 and this is 4, right? And dot 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 dot, but if I multiply by r, I got rid of this -1. Does that make sense? So it'll be a to the r. Is that okay? I stop at a to the r, a to the rn. Sorry, a to the rn, because I multiply by amount of term and I multiply by r, and that is gonna be kind of stop right before that, because r times r to the -1 is equal to 1. Is that okay? Now what we're gonna do is we're gonna subtract those two. We're gonna come up with a different color. We're gonna say, okay, that's blue. We're gonna take it Sn, subtract r to the Sn. You subtract them. What happens if you subtract them? They all cancel out. Boom, 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 boom. Right? And this probably cancel out something here. But then you're gonna have one extra mark here. You're gonna cancel out, let's just say, I'm gonna show you this color. This one is gonna cancel out this one, because all the diagonal part except the 2n on the vertex is not gonna cancel out. So that's gonna be equal to a plus or minus, sorry, you're subtracting, so you're subtracting, so a minus a r to the n. And then you're gonna take out an a. And you're gonna take out a Sn. And then you can say Sn is equal to a times 1 minus r to the n over 1 minus r. Do you see that? And this becomes a finite geometric series. Then you say, well, how do I turn finite to infinite?
Just limits.
Yes, apply limits, but also it has condition, right? How to go from finite to infinite? It has to have one condition. That condition is what? R has to be what? Less than 1, right? If r is less than 1, then I'm going to say a times 1 minus r to the n over 1 minus r. And then r is less than 1, but we are applying limit just like Daniel says. If I apply to infinite. Now imagine, Austin, come back to me. R is less than 1, which is, I'm going to pick a value. What's the best value to pick? Maybe something like easy to comprehend, half, right? So imagine we are this part, we worry about this particular part. If we have 1/2 to the n, and with the limit n approach infinite, what will happen? Zero, right? So would that be a over 1 minus r? And this becomes a finite. I'm going to apply both. I'm going to apply both. How do I say apply both? If I want to apply both, then I'm going to say, well, I'm going to, for example, that one pizza situations, right? The first day, day 1, I'm going to eat 1 pizza. Day 2, I'm going to eat half pizza. Day 3, I'm going to eat a quarter pizza. Is that okay? And of course, this series, the sequence going down, but we are worried about series. So the series is only plus now, right? So this is if I want to add first three term, would that be called S3? Does that make sense? So that's sum of first three term. We want to prove it is right. So we're going to apply this formula here. S to the 3. What is A?
1.
Good. What is R? 1/2. Good. So it'll be 1 minus 1/2 to the what power? Third over 1 minus R, which is 1/2, right? We're gonna show you S3 works. S4 would work too if you do it. I don't want to do it, but I'm too lazy. I'm just gonna do S3 because it's easier calculation. So 1 minus 1/8 equal to 1/2. And this is 7 over 8 1/2. And that's 7 over 8 times 2 over 1. So 7 over 8. 1 plus 1/2 plus 1/4 is equal to 4 over 4 plus 2 over 4 plus 1/4, 7 over 4. Do you see that finite series work? Except I don't need to combine fractions. I can apply a formula. If I do s to the 10, I can evaluate that.
Oh, it's the one on the other side is supposed to be 14 over 8.
Yeah, you're right. 'Cause
On the
you
bottom
said
right.
you said 7 over 8 times 2 is 7 over 8.
Oh, this one's 4. Yeah, you're right. So this one's 4. My bad. Okay, 7 over 4. 7 over 4. See, this is using the finite geometric formula. And this is using regular adding addition, right? It work. Formula work. Let's try. We know it's 2 pizza if I go to infinite, right? Let's try if it works as well. So we know the geometric formula is infinite is this. So it'd be 1 over 1 minus 1/2. 1 over 1/2. 1 times 2 over 1. 2. 2 pizza. Boom. Super concise, super useful. And this idea is going to use this idea to learn something called power series later. And you can represent any function using power series, which is cool, right? Which is really, really cool. But you have to be R has less than 1. So it cannot be anything. So that's the interesting part of it. So R is equal to 2 here. No, wait, the sum is equal to 2. That's infinite sum. Am I losing anybody? Yes, no, maybe? Okay. So with that being said, we finish this part. Geometric. Now we're gonna say, let's start with a couple questions. See if you guys know how to do it. Now make sure, I'm gonna give you a tricky one here. Is this sequence, is this series able to evaluate?
Well, it's what do you call it? Also, let me think.
I'm gonna say no,
Why not?
because R would be it's like it's greater than 1.
Yeah, R is greater than 1. It's really tricky, right? Pi over 3.
Yeah, 3.14 over 3.
3.014 over
I think
3.
that's true,
Yeah. So R is greater than 1. So diverge. You'll finish the problem. You don't need to do any further work.
Yeah.
Pretty wild, right? It's like this is how SAP exam will trick you, is to knowing if you knowing the value of pi. Or if I put an E there, it would work. But if I put a I over there, it doesn't work.
Wait, with this like question, kind of like that beyond the exam.
Yeah, I have seen that.
on FRQ, like where we got.
I have seen that on multiple choice.
A few days ago, you were talking about a series kind of like the 1/2 one, except it was like every fraction started in like 1, 1/2, 1/3, 1/4. And you were saying like it definitely goes to a finite value, but nobody was able to like figure it out yet. Why couldn't you just use that formula?
If a 1 plus 1/2 plus 1/3 plus 1/4, that doesn't. That's diverge series.
It diverges.
Yep, it diverges.
It doesn't go fast. That's the reason.
Well, it's going too fast. That's why it diverge. But this one convert the previous case converge because 1/2 is r is less than 1. But if you have 1, 1/2, 1/3, 1/4, it's not multiplied by the same number. If you pay attention, 1 to 1/2 is not multiplied by the same number. 1/2 to 1/3 is not multiplied by the same number. 1/3 to 1/4 is not multiplied by the same number. So the r is actually it's no r. It's not geometric series.
Okay, now that makes sense.
Okay, so now I'm gonna give you another questions. Yep, please.
You also remember when I answered that? It's 3 last year, bro.
Who?
Miss Lakina, Miss Olga.
Lakina?
You can choose me. I'm Mr. That's what I said. Engineer.
You said you meant to.
Like, well, what they forget? I forgot what. Like, I said.
Yeah. He is in a virtual school. Do you think I can talk to him? No, I need to speak to him face to face. Okay. Can I send the student welcome back?
The shots.
All right. Can I yeah. He need to fix my computer.
Just fix.
Okay, thank you.
Can't do it
Walk
very
in
well.
front to get the student name.
Oh, I can't do this one at all, but I did. Okay.
Walk in back to just install the wall.
You do that, right? That's like easy for me. Oh,
Do it on this hand, but.
Thank you. Now we're gonna talk about this one. What is this series, right? So what if I have series write out like this? I can write out like this. So so this series is write down like terms. I show you the terms, right? So is any way I can convert it to this? So anyway, I can convert it to this. How do I figure out what A1 in here? How do I figure out A1? What is A1?
Wait, is it would it be a 5/3 times 1/3? Wait, 5/3?
Is it 5?
It's not 5.
-5.
It's not -5 either.
Wait, what's the question? What are we trying to do?
How do I convert this to a geometric series?
Yeah, so it'd be 5/3, right? Times parentheses 1/3 times -1 to the n minus 1 close parentheses.
Okay, so how do I get to that step though? How do I get there?
Smart boy.
Let's just like how.
Yeah, how do I get there? So you want the first term to be, and the result of R is going to be 1, right? So you want this to be 1. How do I make that become 1?
Just write it down.
You can factor it out, right? Does that make sense? I can factor out. I can factor out first term, but you visually make sense. You understand it because you see that term afterward. Really good, right? So then I can rewrite this as n equal to 1 infinite of 5 over third, right? This is going to be negative 1/3 to the m minus 1. Now, if that's true, I can find out a finite series. How do I find a finite series? 5/3. Does that make sense? 1 is a minus or plus?
Plus 1/3.
Plus 1/3. See that? Because that's negative, right? So that's going to be 5/3 over 4/3. So the result is going to be 5/4 on this case.
That's pretty cool.
I would say most of you guys in this classroom will actually enjoy this type of stuff because no longer like tedious work, it's more thinking work.
Yes. I like that.
Yeah, the tedious work is like when they're doing chain rules and like all that shit. But now you're doing like a very simple work, but you have to think a little bit.
Making me redo the methods we had with calculators and FRQs, like with the gravel and the spark force.
Oh. I misread, bro.
I just want to make sure you got through that.
It's understandable because I kind of like got the entire test wrong the first time. Like,
Yeah.
kind of, you know. but
Yeah.
it's,
Is that okay for here? Okay, so I want you to try this problem. And be careful with this problem. Should I give you an answer or no?
Oh,
Probably don't give you an answer, right? The idea you have to be r to the n minus 1 though. You have to somehow convert a1 r to n minus 1. You have to do some mathematical manipulation to get to that point. Austin, you're gonna have to watch a video when you're home. But you do look like shit, so you just go sleep. Put your head down, go sleep.
This is not a good idea. Streaming right now.
Yeah, you look like shit, so.
you were actually playing 2K all night.
I wasn't playing 2K all day.
On the phone? Come on.
Oh, nice.
I want to play 2K on the phone? That's like,
This is making me mad. I'm actually yelling.
Were they missing too much?
Huh?
Were they missing too much?
Yes, bro. Like, why are they trying to cut? I'm trying to pass it to them in the corner.
You should fade. Why don't you should fade every time?
Just make sure I get this question. You're saying we have to convert this to the A1 R n minus 1?
yeah, convert to that and then do it, then you will do it right. Because sometimes, I understand, you might be able to do something, but, you know, I would rather you get a right answer. That form is a perfect form to go to. But you do need know some exponent rule skills.
Yeah, I got that part. You get 1/3. But you factor out the exponent, or whatever that's called. I don't know.
You have the targeting on the full speed.
Yeah. Because you're
Chung! I miss you.
Miss you too, Mr.
Where you been?
Panera.
How's life in Panera?
Good, good.
You like working? You prefer working?
We're waiting
From
on
school?
Yeah.
I mean, money.
You don't miss
money's
school?
good. I do miss school, but I mean, I'd rather just have 2 classes. I've already gotten into UCF.
Oh, you got any?
Yeah.
Oh, congratulations.
Yeah, thank you. I'm still waiting on FSU. And
What are you gonna
UF.
major in?
Probably computer science. That's probably the closest thing that I have to.
You know you had to do calculus over there, right?
Oh yeah, I'm excited.
No, calculus UCF suck.
Well, we'll see. I can always just text you and you can help me out if you need.
Well, I can. That's fair. That's fair. You're gonna help me with computer.
Yeah,
Give me a second. Let me finish this problem. Do you think I can finish
no
this problem?
problem. I got you. I got time. I got until 3 45.
And do it. You
I
can.
think I got
Okay. What's your answer?
e over 9 times 1 to the power of n minus
What?
n.
No. The final series number. What's the final series?
Oh,
Number? Oh, e over what? What is it? Let me see. E over
I
nine.
mean, no, I got like the
First part. Okay.
yeah.
What is
e
that
over
first part?
9 times 1 to the n of minus
Times 1/3 to the n.
1. No, just 1.
But there's no one.
And then you can like
No.
Multiply.
A little bit off. A little bit off. Tiny bit. Tiny bit.
You multiply.
12 times 3.
You multiply and you divide by it.
So you just play. You sit at home playing Spider-Man.
There you
I mean, a few months ago, yeah. But that's I already finished it. I don't have anything else to do.
No. What do you do?
My 2 classes, and I read.
Okay.
That's it. That's pretty much it. I go on my phone.
Does your mom hates me?
So we get 1 over e.
No, I think she hates me more actually.
1
She's always like, Sean, you did your assignments for the day. Why don't you do more? And I'm like, because I don't.
Oh, you're the minimalist.
I'm not a minimalist. I'm supposed to do 2 assignments a week. I do 2 a day in each class.
Ah, okay.
So I'm like, I'm still doing good, but she.
What's a? E over 9.
It's a struggle for sure. I was talking to my dad about it today. I was like, I'm gonna finish before graduation.
That's true, yeah.
Mhm.
Is it 3 over 3e minus e squared?
I think it's a little bit off. The answer I have here is e over 3 minus e.
Yeah, that's not.
What do you put for n?
N is like infinite.
I can't believe you drop out though. Because my class, because you drop out.
Is it
No.
average?
No, it was honestly like your class. It was obviously like difficult, but like I was fine with that.
No, you were smart enough for it. I would say that.
I was interested in trying it. Like this was like one of the classes where I was like, ooh, like this is kind of part of the reason I wanted to stay. But like other classes, it was definitely just I wanted to. Man, the only thing that I prefer about work over school is
I
that
got
you
e
get
over
credits.
6 squared.
That's true. I don't blame you.
But like that's
But the Panera doesn't pay,
no, it doesn't.
and they have a shitty management.
Yeah, but it's more of like
So I got subtract 1.
I was always stressed
We all
out
have 1 over
like
e.
with a bunch of stuff here. Not even schoolwork necessarily, but just
Oh,
like
interesting. So you don't have to change it.
I was like,
Yeah, might as well.
if I can just
And then
do the 2 classes that I
Put it
need
in here.
and make money and be happy,
I
Then I'd
just
rather do
did
that.
like this, but I wrote it out like in terms with the pen, and then I factored out e over 9.
but
Yes.
there were definitely a few classes where I was like,
Okay, so what I would do is I will take out 1/3 first,
And then I just put it
and remember this n can be on the top, right? This n can be on top here. That's the thing. But the problem is in the wrong term, wrong spacing, because you're not n minus 1. So what you can do is you can take out another one times 1 e over 3, right? So now it's gonna be e to the over 3 to the n minus 1, right?
We almost got that. We just
Oh.
made a
How come this doesn't
Yeah.
work?
So
Oh,
It is
that
not
was a-
reciprocal.
So summation n equal to 1 infinity e over 9 times e over 3 to the n minus 1. And then now you are in the correct geometric form. Now you can say e over 9, 1 minus e over 3. Then e over 9 over
would be
3 minus e over 3. E over 9 times 3 over 3 minus e. So that's cancel out 3. E times 3 times 3 minus e. And that will be the answers here. And yeah, so
that's
No, I got e over. Bro, I'm so tired.
e over 9. No, you had e over 9.
Okay, I got e over 9 times
Oh my God,
1/3
it's really
n minus 1,
January.
or 1/3 to the n minus 1.
that's
So it's
weird.
supposed to be e
I
over
kept
9.
thinking it's like November. You guys are in like the first semester, but you're already out. Oh
Mhm.
my god.
Oh, dude, that was so close. I just forgot the e.
I'm sorry.
Bob had a different method. It was kind of a lot easier though. I don't know if it works for the rest of the problems, but he wrote out first term, second term, third term,
in factor out.
Yeah.
Yeah, it's probably that's what last period somebody says. I think Rogov does some of the things. Because you want the first term to be 1 though.
No, one. That's my peak. That's it. Peak January. What's the date? January 12th, 2020.
I wrote the wrong date on my test. That's right.
Okay, so this one, however, this one is not geometric or arithmetic or the things. This is called a harmonic series. Very well known series is harmonic. Harmonic is not geometric.
Where's this better?
This one is gonna be
No.
diverge.
Sorry, I can try.
I swear you gave us this at the beginning.
Not really, but I'd still like to try.
You don't know. You don't know this.
I have no clue, but
Yeah, you have no clue.
let's see. Which one? Alright.
Or maybe it was the odd ones. Maybe it was.
He
I think
doesn't
it
know.
was 1/3, 1/5, 1/7.
It's
I
okay.
remember part of it. The 8 goes to 0.
All right, so this one's a diverge series. This is very well known. This is a diverge because this is called a harmonic series. Harmonic series. This is the only one I need you to memorize by name. Harmonic series, it's very important. It's like a borderline diverge. It's very borderline. I'm going to explain to you why it's borderline because later on we're going to learn something called P series. But if you have, a long time ago we talked about, on the 2 tests ago, we talked about this. If you have 1 over n to the 1.00001, this one converge. 0.99 or 1 is diverge. So n equal to 1, this is a converge. Because this is greater than 1. So this is called P series. P series, we're going to learn that later. I'm just going to give you a kind of fast course. P series basically is summation of n equal to 1 of summation 1 over n to the p. If the p is greater than 1, converge. If p is equal to 1 or less than 1, diverge. So 1.00001 is greater than 1 is converge. Equal to 1, harmonic series, diverge. Harmonic series, it's the series I need you to know my name. We know telescope, we know geometric, and we know harmonic. Harmonic is pure memorization. And you also learn P series in some sorts of way right now. Now, I mean, it's pretty easy. P series is pretty easy.
Wait, Mr. Do you know how to prove that it's divergent?
How to prove
Yeah.
harmonic? Yeah, there was a proof, but I don't remember. But if you think about it, if you eat, like, just a very logical proof, let's just say 1 pizza, 1/3 or 1/2 pizza, 1/3 pizza, 1/4 pizza, 1/5 pizza, it's still continuous growing, but it's growing very, very slow, but it's gonna break the threshold. So the one of the things that I thought about is using that 1 over x graph, and that's called Gabriel's horn from 1 to infinite. If you do if you can do like a improper integral, that is gonna be diverge. Do you remember that?
Yeah.
So that's the easiest proof I can think of, but there was a lot of different proof. Like use integral test, use integral, but use an improper integral. Use improper integral for 1 over x. I would do that, but harmonic is just no. Like professor would just tell you to memorize this series always diverge.
How do you know that like the integral would be the same as like a series? Because like a series is like several steps, while an integral is like a smooth.
Yeah, it's still so integral test is a very good approximation of what is going to be. It's going to be, I forgot it's less or more, but they have a thing that it says the actual integral and versus the C series. I think it's the actual integral is greater than the actual series, the sum of the actual series, but it's still good indication, I will say.
Thanks for another great Titan day. Students, you are now dismissed.
Okay.
This one was big.
So I have big